5, 4, 3, 2, 1, 0, plus 1, 2, 3, 4, 5, 6 of normal, 7.
Combustion technology is widely adopted in both ground and air transportation, including rockets, in thermal power production, and in prevention and suppression of fire hazards. It is in view of these wide applications that the National Centre for Combustion Research and Development, or NCCRD, has been established at IIT Madras and IISc with the support of the Science and Engineering Research Board, Government of India. The NCCRD at IIT Madras is the largest of its kind in the world in terms of interdisciplinary diversity of its faculty, drawing from across 6 departments. With its 5-story main building and a few other smaller buildings, the propellant combustion building, the fire test enclosure, and a compressor room, it also has a large floor space of around 35,500 square feet for combustion research, the foremost in an academic setting anywhere globally. The NCCRD boasts of state-of-the-art equipment such as the Evolved Gas Analysis System, comprising the hyphenated technology of thermogravimetric analyzer with infrared spectrometer and gas chromatography with mass spectrometer, high-pressure TGA, cone calorimeter for flammability testing, phase Doppler interferometer for detailed spray diagnostics, and 4-camera high-speed tomographic particle image velocimetry and planar laser-induced fluorescence.
A lot of progress has already been made, and many research topics have been investigated into low emission burners, then characterization of fuels, stability control in gas turbines by optimizing the shapes of swirlers. In automotive combustion, optical engines have been developed in collaboration with TVS, direct injection in automotive engines to reduce the emissions. Our faculty are working on municipal solid waste incineration in collaboration with BHEL.
Extensive test facilities include high-pressure spray rigs for continuous and pulsed sprays and combustion, automotive test cells and optical engine, supersonic combustion tunnel, 100 kilowatt thermal level gasifiers, open calorimetry for fire testing, and microgravity drop tower. For automotive research, 4 engine test cells are available for complete testing of SI and CI engines and a GDI research engine.
Basically, this is one of the state-of-the-art facilities comparable to what you see in the industry, automotive industry in India. Here you have 4 test cells, and these 4 test cells can all be equipped with any kind of engine. We can take even very big engines, and we can even modify these test cells to take even an automobile. We can even have a chassis dynamometer because these test cells are fairly large, and you have all the infrastructure required for the coolant flow, the exhaust flow, the ventilation, the soundproofing, whatever you require is in place.
Chennai being a major hub of the automotive industry, a close interaction naturally exists with several companies in the 2, 3 and 4-wheeler segments, including buses and trucks.
The ongoing engine research in NCCRD is in line with the global trends and also Mahindra's interest in pushing the limits of gasoline direct engines performance so that we can use it to power our future light-duty vehicles. The transient test facility, emission measurement systems and the expertise in engine control that has been built in NCCRD can be leveraged by the Indian automotive industry to venture into areas such as control logics development for our future hybrid electric vehicles, specifically for Indian driving conditions.
A comprehensive fuel characterization lab is productive in cataloging a database of pyrolysis behavior of various solid and liquid fuels with catalysts, aimed towards synthesis of alternative fuels and curbing emissions.
This lab actually houses a variety of analytical instruments that can be used to characterize and perform detailed studies on a variety of solid feedstocks, including coal, biomass, municipal solid waste, and complicated feedstocks like plastics and so on. The main objective is not only to characterize these materials as such, but we would also like to understand the thermal decomposition and also the thermal behavior of these materials when subjected to a variety of operating conditions.
The need for clean coal technologies such as gasification for power as well as methanol production has led to the establishment of relatively large-scale bubbling and circulating fluidized bed gasifiers at the 100 kilowatt thermal level, which serve for industrial collaboration with major players such as BHEL, Thermax, etc.
Based on our fluid bed concept, we are taking to a gasification, and that's where Association of NCCRD and IIT Madras has given us a tremendous strength. Here we are working on a 1 megawatt high pressure coal gasifier, which is now running very smoothly thanks to the work and the input that we got from IIT Madras and NCCRD. So as India is moving forward to the clean coal technologies, our COP21 commitments, as well as making ourselves self-reliant in the field of oil and gas via coal, these technologies will go a long way, and I'm sure our collaboration with NCCRD and IIT Madras will grow in the years to come. Thank you.
Spray atomization is an area of intense research with particular focus on high spatio-temporal diagnostics of injector geometries used practically in engine.
Spray diagnostics is one of the very important things that we are doing at NCCRD. We are particularly looking at very practical applications. So this is one of those setups which is a high pressure spray rig for continuous sprays, and this is actually meant for doing aerospace sprays similar to what happens in gas turbines, gas turbine combustors. As a matter of fact, we have been testing a gas turbine combustor that goes into an actual aviation engine of a commercial aircraft at fairly elevated pressures over here. And we have been looking at sprays that are actually obtained by wall filming of spray impinging against a wall and going through a secondary atomization process in a fairly incredibly high spatio-temporal resolution of a few millimeters by few millimeters dimensions, and about tens of kilohertz worth of framing rates, doing volume elimination and doing laser-induced fluorescence of a volume eliminated region. This kind of behavior is used now to actually deduce wall filming at around a few microns kind of resolutions at very, very high repetition rates. And we do this in the high pressure environment, and we find that the sprays are actually extremely differently behaved when compared to an atmospheric pressure spray. So this is actually bringing us some completely new knowledge that could be used in modeling and simulation behavior that can be used for designing better and better injectors for more compact combustors in future aircraft engines.
Our engagement with industry has led to co-development and research of small-scale practical combustors and micro-gas turbines.
GE Aviation has been partnering with NCCRD very successfully. NCCRD brings with it state-of-the-art equipment, experimental facilities, and a talent pool of faculty, researchers, and technicians. We bring in the expertise of product development. Working together, we've been able to push the boundaries of technology in the domain of low-emission combustors.
The microgravity drop tower of NCCRD is the 5th largest in the world, 38 meters tall and with an estimated 2.5 seconds of residence time. It has a capsule-in-capsule system along with release and catcher systems, onboard high-speed camera and instrumentation.
This is a unique facility, the only facility in India, and there are like 7 such facilities with drop duration of around 2 seconds, more than 2 seconds around the world. 3 in United States, 1 in Germany, 1 in Japan, 1 in China, and our tower stands like number 5th in terms of duration of drop. Our idea was not to aim for number 1 in terms of drop duration, but to have a facility which will enable sustainable research in an academic environment.
Fire research is an area gaining expertise at NCCRD. The focus is on characterization of flame retardant polymers, fire sprinkler and water mist suppression systems. A strong combination of diagnostics and modeling go hand in hand in these research efforts.
Dear colleagues of IIT Madras and National Center for Combustion Research and Development, on behalf of FM Global, I would like to congratulate all of you for the research building inauguration. This is certainly a very exciting moment for the professors, staff, and students at NCCRD. And your colleagues from FM Global send our best wishes.
Several innovations are being developed, such as the swirl mesh lean direct injection for gas turbine combustors, microsprays, rotary MSW combustor, X2 liquid technologies by catalytic fast and microwave pyrolysis and hydrothermal liquefaction, low-cost optical IC engine, inline sensors for non-standard gaseous fuel composition, steam quality, coal composition, precursor detection for flame stabilization and combustion instability, and spray tomography. These are leading to patents, which are translating into industrial applications and spawning startup companies.
NCCRD's unique feature is doing things at scales that are more relevant to industry. So we actually are working in an area which is just above what we would do in a typical lab in an academic institution to what would actually be implemented in the industry. So we actually do a bridging between lab to industry scale of testing, as well as things like prototype development and so on, at a scale that is affordable here but also industry relevant.
This is one of the its own unique facility actually created in India. So that's a good sign actually, and I'm sure actually this will further continue.
The National Center for Combustion Research and Development is a premier research center set up for the country at IIT Madras and Indian Institute of Science, Bangalore. Here at IIT Madras, it brings together faculty from more than 6 departments, numbering more than 30 in diverse disciplines to address interdisciplinary area of combustion as applied in 3 very different verticals. As we all know, energy, carbon dioxide emission, and emission of pollutant gases, all of these have become very important because of the global warming, climate change and other such impact that combustion has. This center will play a pivotal role in making sure that India has access to the latest technologies in all the areas that I mentioned. We are very excited about having this center on IIT Madras because it gives us an opportunity for people from multiple disciplines, students from various departments pursuing different lines of study to work together to solve the challenges that face the nation.
I'm Seshadri from the University of California at San Diego. It gives me great pleasure to congratulate you on the establishment of the National Center for Combustion Research at IIT Chennai. The faculty and students at Chennai have been in the forefront of combustion research, and with the establishment of the NCCRD at IIT Chennai, scientists all over India will have the best facilities in the world to continue to make pioneering advancements in the area of combustion science and technology, train graduate students, and contributes in a significant way to the prosperity of the nation and energy security. Thank you.
Forman Williams from the University of California, San Diego. I'm happy to make a few comments at this celebration. I visited IIT Madras a few years ago. It gave a lecture series. At that time I discovered that the faculty and students there are really first class. That's the first thing that's needed in a first class institution. I also saw the construction under progress, and I'm really pleased to see that that construction is now complete, and I expect to see really world-class leading advances in combustion from IIT Madras because of these notable accomplishments.